Welcome back to the deep dive. Today we're wading into some pretty dangerous waters.
We really are. This is one of those topics, you bring it up at a developer conference and
And you've either made a best friend or a mortal enemy in what, 5 seconds?
pretty much, yeah.
We are talking, of course, about stored procedures,
Hmm.
or sprocs, if you're into the jargon.
Sprocs. It kind of sounds like a bad 80s robot villain, doesn't it?
It really does. But look, depending on who you talk to, this technology is either the bedrock of enterprise stability,
The thing keeping the banks running.
or it is an absolute architectural nightmare that should be, killed with fire.
Right. And that might sound like really dry, techie stuff, but the debate is actually, it's fundamental. It's about where the brain of your application should live.
Okay, so does the logic, the thinking, live in the application layer?
Or does it live deep inside the vault, in the database layer?
Exactly. And to figure this out, we've got a really interesting stack of sources. We have some classic, almost angry rants from legends like Jeff Atwood.
The Stack Overflow guy. So he's seen a few things.
A few things, yeah. We've got modern breakdowns from the Dusted Codes blog and some pretty intense war stories from developers on Reddit.
And then the part that I think is going to surprise people, we have this forward-looking piece from late 2025.
From Syntaxia, right?
Yeah, and they argue that stored procedures might actually be blocking the adoption of AI.
That part blew my mind. We are going to get there. But the mission for today is simple. Why did this thing, which was once the gold standard, become what people call a trap?
And is there any good reason at all to still be using it today? It's a journey, I think, from the blast furnaces of the 2000s to the AI models of tomorrow.
So let's start at the beginning. For anyone listening who's maybe nodding along but isn't 100% sure, what exactly is a stored procedure?
Sure. So think about a normal app. You write code in, say, Python or C#. That code needs data.
Right.
It sends a query to the database, grabs the data, brings it back, and then does all the thinking.
So the app is the brain, and the database is just the filing cabinet.
Exactly. With a stored procedure, you flip that on its head.
Yeah.
You actually write a bunch of code, a bunch of logic, and you save it inside the database itself.
So it lives right next to the data table.
Right there. You give it a name, like process order or something, and it just lives there.
So the database isn't just a filing cabinet anymore. It's doing the thinking.
That's the idea. Yeah.
Yeah.
It executes logic right where the data is.
Okay, so on the surface, that sounds, I don't know, efficient. But when you read these sources, efficient is not the word developers use.
No. Painful comes up a lot.
It does. And Jeff Atwood, in his classic critique, he calls them database assembly language.
Ouch. Yeah.
That sounds tedious.
It is. I mean, he basically argues that, yeah, they're powerful, but the actual experience of writing and maintaining them is just miserable compared to modern code.
He brings up this black box problem, which really stood out to me. If your app crashes...
In your normal code, your tools tell you exactly where it broke,
Yeah.
right? You're in your IDE, your custom...
Debuggers, you have all this help.
But if the error happens inside a stored procedure, you're flying blind.
Atwood says you have to, stop what you're doing, open a totally different program,
Something like Toad or SQL Management Studio.
and then go hunting for what happened.
It's a massive context switch. It's like you're a chef, but every time you need to chop an onion, you have to leave the kitchen and go out to the shed to do it.
It just breaks your flow.
Completely. You lose your whole mental model of the problem.
And speaking of breaking flow, he had this example that made me physically cringe, the 20-parameter nightmare.
Oh, that's a classic, a real classic pain point.
So explain that. Why is it so much harder to pass data to one of these things?
Well, in modern languages, we use objects. If I want to update a user's profile, I just pass a user object. It has the name, the address, everything all bundled up.
Like handing someone a suitcase.
Perfect analogy.
Yeah.
You hand over the suitcase. But stored procedures, generally, they don't do objects. They're flat. So you can't hand over the suitcase.
You have to. Unpack it first.
You have to unpack it and hand over every single sock and shirt individually.
So you're not sending a user, you're sending 20 different things.
Exactly. Parameter 1 is the name, parameter 2 is the zip code. And Atwood points out if you mess up just one of them,
You get a generic error.
yeah, a bad call error. And you don't know which one is wrong, so you have to check all 20 by hand.
That sounds absolutely infuriating.
It's tedious, it's error-prone, it's archaic.
And there's another layer of pain the Dusted Codes source talks about, and that's testing.
Oh, this is maybe the biggest deal breaker for modern development.
Unit testing, right. We test small pieces of code in isolation.
Yeah, we mock data, we fake it. It's like a flight simulator. You don't need to crash a real plane to test the landing gear. It's fast, it's safe.
But you can't really do that with a stored procedure because it's stuck inside the database.
Exactly. You can't mock the data because the code is literally inside the database engine. To test one little function, you have to spin up a whole real database.
Create tables, put data in them.
Run the test, and then tear it all down. Something that should take milliseconds now takes minutes.
And if you have thousands of tests,
Your test suite takes hours. And then developers stop running them. And then bugs creep in.
it's what dusted codes called the maintainability cliff. Logic crosses that line into the database and just falls off a cliff.
And Atwood has this great sarcastic line where he says, JavaScript is a giant step up from database languages like PL SQL.
And given how much people used to hate JavaScript, that's a serious burn.
It's a deep cut, yeah.
Okay, so if the developer experience is a nightmare, why were they ever the standard? I mean, a Reddit user said in the aughts, the 2000s, they were table stakes.
To get that, you have to understand the environment back then. This is what we're calling the blast furnace era.
I love that phrase. It comes from a Reddit user, F0TNMC.
Yeah, they told this amazing story about working on a production Oracle database that ran so hot, the DBAs were blast furnace focused, just on stability.
They were using mainframes, planning migrations over months.
Exactly. And you have to remember, in 2005, networks were slow, like really slow. Bandwidth was expensive. The round trip mattered.
The round trip. Explain that.
Okay, so your app is at a table in a restaurant. The database is the kitchen. If the kitchen is a mile away, you don't want the waiter running back and forth for every single thing.
You want them to bring everything at once.
Precisely. If the network is slow, you want to do as much work as possible in the kitchen. That's data locality.
Running the code where the data lives.
Yeah. You process the data there and just send the final answer back.
Yeah.
One Reddit user, Coffee with Alex, said they replaced a slow app in 2008 with DB-side queries, and it ran thousands of times faster.
Thousands of times. Okay, in 2008, that's not a small thing. That's the difference between your app working and not working.
You put up with the pain because you absolutely needed that speed. But, and this is the crucial part, that performance gap has largely disappeared.
How? The laws of physics haven't changed.
No, but the infrastructure has. Networks got incredibly fast. We're talking 10 gigabit speeds inside data centers now. The cost of that round trip is, for most apps, just noise.
The waiter is basically a superhero now.
Right. And secondly, as Atwood points out, databases got way smarter. They do things like just-in-time or JIT compilation for any query you send.
So they optimize it on the fly, even if it's not a stored procedure.
Exactly. That performance superpower just isn't a superpower anymore for like 99% of cases.
So we solved a hardware problem, the slow networks, but we created a massive software problem that we're still dealing with now.
Which brings us to the hellscape of maintenance.
Right, the fear of change.
The Dusted Codes article really nails this. Because the tooling is so bad, developers get terrified to touch a stored procedure.
It's the Jenga tower problem, right?
Totally. You have a sproc called update customer. You have no idea what calls it. Could be the website, could be the mobile app.
Or some ancient reporting tool nobody's touched in 5 years.
And there's no find all references button that works across the whole company. So if you change it, you might break something, and you won't know until the CEO is yelling at you.
And unlike our application code where we have Git and can see who changed what and when.
With sprocs, that history is often just gone. It's a black hole.
There was that one horror story on Reddit. A single stored procedure that was 5,000 lines long.
A 5,000-line script. I mean, can you even imagine trying to debug that? It's a monster. It's completely unreadable.
And that leads to the other big modern argument. The bottleneck, this is about scaling, right?
Yes, this is so important. It's vertical versus horizontal scaling.
Okay, break that down for us.
If all the thinking, all the logic is in your database, the only way to make your app faster is to make your database server bigger.
That's vertical scaling, a bigger, more expensive computer.
And database servers are incredibly expensive.
Mm-hmm.
And eventually you just hit a wall. You can't buy a bigger one. But if the logic is in your application layer...
You just add more cheap web servers.
Exactly. That's horizontal scaling. You just add more cheap servers to the fleet. It is so much easier and cheaper to scale that way. By putting logic in the database, you're creating a bottleneck at the most expensive part of your system.
Okay, so let's recap. Bad developer experience, a performance game that's mostly gone, and a maintenance nightmare. The verdict seems pretty clear.
You think so?
But This is where it gets really weird. This is the 2025 angle from Syntaxia.
This is the plot twist.
They're arguing that stored procedures are actively holding companies back from using artificial intelligence. How on earth do they make that leap?
This is where it all connects. They talk about something called the semantic gap.
Semantic gap. Let's unpack that.
So AI models like LLMs are very good at reading code.
Yeah.
You can show an AI a Python function, and it can usually figure out what the code means.
The semantics, right?
But Syntaxia argues that while an AI can read the code of a stored procedure, it struggles with the intent.
The why behind the what.
Exactly. They use an example, speed calculate asset performance. An AI can look at that and say, okay, this joins table A and table B, then filters by date. But it has no idea why that specific join represents a business rule.
The business logic is lost in the plumbing.
It's buried. It's hidden in all these procedural steps. It's implicit, not explicit.
And they have this brilliant term, cognitive latency.
I love that term. It's a total shift in thinking. In the 2000s, we obsessed over hardware latency, disk speed, network speed.
Right.
Their argument is that in 2026, the real bottleneck is cognitive latency. How fast can a human or an AI understand what a system is actually doing?
And stored procedures are a brick wall for cognitive latency.
They're totally opaque. And there's another problem. Modern AI uses things like vector databases and raw join pipelines to work with data.
To give the AI context so it knows about your specific business.
Exactly. But stored procedures are so tightly coupled to one specific database like Oracle or SQL Server, they're rigid. You can't just feed that logic into a modern AI pipeline.
So you're essentially hiding the instruction manual for your business inside a safe that the AI can't open.
That's a perfect way to put it. It's not just tech debt anymore. It's a strategic liability that stops you from moving into the next era of computing.
Wow. Okay, so things are looking pretty grim for the sproc. But we have to be fair. Is there any good use left for them at all?
Well, there was a really nuanced take on Reddit from a user, Stolen Studs. They called it the interface strategy.
The idea of using them strictly as an API, right?
Exactly. The argument is, if you do that, it actually decouples your application from the database's internal structure.
How does that work in practice?
So let's say your app calls a procedure named getUserData. Behind the scenes, you as the database admin can completely refactor the tables. You can split one big table into two.
And the app would never know.
The app would never know. It just keeps calling getUserData. The procedure acts as a stable contract, a safety layer.
Okay, so that sounds like a valid, disciplined approach.
It is. The problem, as that user admits, is that it's a very slippery slope.
People rarely stop there.
Right. They start with a simple interface. Then they say, well, while I'm in here getting the data, I might as well, calculate the tax.
And while I'm doing that, maybe I'll just send a quick confirmation email.
And boom, you're right back to the 5,000-line monster. You've put the business logic back in the database.
So what's the final consensus? If you're starting a project today, what's the recommendation?
The consensus from pretty much all the sources is to treat them as a last resort.
A break glass in case of emergency kind of tool.
Exactly. If you have some super high volume transaction that needs to lock 5 tables at once with absolute consistency, okay, that's database assembly language work. Go for it.
But for everything else?
The golden rule seems to be, keep your business logic in the application. Keep your data access just getting the data in the database.
It's like we've come full circle. This started as a solution to a hardware problem.
Slow networks, spinning disks.
Then it became a software problem.
Unmaintainable, untestable code.
And now it's an intelligence problem.
Blocking AI from understanding what's going on.
It just shows how our definition of good code changes. It used to mean fast code. Now it really seems to mean understandable code.
That's the huge takeaway. We've shifted from prioritizing machine efficiency to prioritizing human, and now AI, efficiency, clarity, intent. That's the new currency.
So here's a final thought to leave you with. If AI really needs transparency and explicit intent to work well, does that mean that any code we write that's clever or hidden, is that just becoming the new technical debt?
That is the big question, isn't it? Are we moving to a world where code has to be written for machines to read, not just for them to execute?
Something to think about. Thanks for listening to The Deep Dive.
See you next time.